Let's find the product of 2 to the 1 over 3 times 4 to the 1 over 9 times 8 to the 1 over 27 times 16 to the 1 over 81, and it just continues forever and ever. Now my hint to you is that there is an Arithmetico-Geometrico series hidden in this problem. We just need to find it. So a good first step in a lot of these exponent problems is to rewrite everything with the same base. Now since we have a bunch of powers of 2, for example, 4 is 2 squared, 8 is 2 cubed, 16 is 2 to the 4th, I think it's a good idea to rewrite this problem with a base of 2. So that would become 2 to the 1 over 3 times 2 to the 2 over 9 times 2 to the 3 over 27 times 2 to the 4 over 81 Now some of you may be tempted to simplify 3 over 27 into 1 over 9, but I'm not going to do that here because I don't think that's such a good idea, and you'll see why in just a moment. Now since all of these exponents have the same base, we can combine them by adding their exponents. So this is the same as 2 to the 1 over 3 plus 2 over 9 plus 3 over 27 plus 4 over 81 And now do you see it? This part, right over here, looks very familiar, doesn't it? 1 over 3 plus 2 over 9 plus 3 over 27 plus 4 over 81 is an Arithmetico-Geometrico series. The numerators are 1, 2, 3, 4, so that's an arithmetic progression with a common difference of 1. The denominators go 3, 9, 27, 81, so that's a geometric progression with a common ratio of 1 over 3. Now the good news for us is that we already know how to evaluate infinite Arithmetico-Geometrico series, so let's call this whole thing S. So what we're really trying to find is 2 to the S. Now let's take this infinite Arithmetico-Geometrico series and take a closer look at it. Okay, so now we're in familiar territory. We know how to evaluate this. This is just an infinite Arithmetico-Geometrico series. Now we've already called the whole thing S, so let's find S. So I think by now we are veterans for solving Arithmetico-Geometrico series. The common ratio of the geometric progression is 1 over 3, so we'll take S and multiply it by 1 over 3 to get S over 3 equals every term in S multiplied by 1 over 3. So 1 over 3 becomes 1 over 9. 2 over 9 becomes 2 over 27. 3 over 27 becomes 3 over 81. Let's take the difference between these two series to get 2s over 3 equals 1 over 3 plus 1 over 9 plus 1 over 27 plus 1 over 81 This is good news for us. This is just an infinite geometric series with first term 1 over 3 and common ratio 1 over 3. So this sum ends up being 1 over 2, which means 2s over 3 equals 1 over 2. So multiplying both sides by 3 over 2 to get s on its own gives s equals 3 over 4. But we have to be very careful because s equals 3 over 4, but that's not the final answer because we were not trying to find s, we want to find 2 to the s. So it's time to take this value of s, plug it back into 2 to the s, and that will give us the correct final answer. Now since we found that s equals 3 over 4, this means our answer that we're looking for is 2 to the s, which is 2 to the 3 over 4, which simplifies to the 4th root of 8. So this was a nice example of a problem that may have seemed very intimidating, but once we did a little simplification, we found that it's just an Arithmetico-Geometrico series in disguise. So even though we didn't see the Arithmetico-Geometrico series right away, after a little bit of digging, we found it.